So very good morning to all of you. And today we are going to talk on discuss on the topic of this machine learning and the components. So we have this particular topic in our previously sixth semester also, where this topic of machine learning was discussed. So those who are from Tumka Engineering College, I don't know what you people, whether you people have studied this machine learning in your sixth semester or not. Okay, so no issue. We are going to discuss it from the beginning again. So, and for our college students, we have already have a discussion of this topic in our previous classes. And as we have covered the syllabuses fully, so again, we are going to start it from the beginning for one more time. And for just for the revision discussion, no issue on that. Right. Okay. So let's think from the beginning that what is the concept of this machine learning and why it has evolved so much into the scenario of nowadays, right? So if we talk about this machine learning concept, the thing is this machine learning, whenever whenever we're trying to talk on the topic of this machine learning, the scenario is it don't have a particularly clear definition. We can say many things on that, right? But the task, the goal of this machine learning is in a very easy or most suitable way, we can say that to predict something, to predict, to make some decision, to make some prediction for the future scenario. Like as an example, if we are talking about, if we say some examples, a very basic example, our mobile weather report, right? So when we are going to see it, we can see that it will showing some updates that what will be the prediction, what will be the future or the upcoming days weather scenario, what will be the temperature, the highest or the lowest temperature. So how it can be done? Also, one more example, we can say the train reservation system, right? When we are going to book some seats on the IRCTC website, we can see that the if there is a waiting scenario, then how much chances are there for a confirmation seat, right? So these are the predictions. So how this prediction can be calculated, how this prediction is done actually. So the prediction is done on the basis of the previous or the past scenarios, that what happened in the last 5 or 6 or 7 or 10 years. A particular range have been fixed, and what happened on that day. Suppose uh, on 31st of January, I'm trying to book a set, but it is showing some confirmation chances of 89%. How it is predicting that there will be a chances of 89% that in the past days, in the last 5, 6 or 7 years, up to this number, the seats have been confirmed. On that particular scenario, there this is going for a prediction that yes, there is a chance of 89% seat booking, right? So the prediction. So whenever we are trying to talk on this machine learning, it will give us a result of the prediction. As a prediction, it will show us some result, and that doesn't mean that yes, this is a correct result. Maybe looking into the scenario that it has chances of 89% of seat booking in our previous past days. So I'm going to book I am going for the seat, I'm going to book the seat, but what happened that my seat didn't confirm. So now what happened, I'm going to blame that it is showing that 89%, but my seat didn't get booking. No, because it is a prediction that yes, it have a chance, but it doesn't mean that you will also get it. So this machine learning, it will give us an idea or assumption that what can happen into the future days, what is the scenario that can happen in our future days, right? So this is the particular scenario. Now looking as a definition, what we can say as a definition, so it is a computer program to optimize the performance criteria using the data or past experience data. So a very classic definition, if I say, of this machine learning, that it is a programming that have computers to optimize the performance. It is a programming for the computer to optimize the performance, or rather say to make a prediction for the future on the basis of past data. So it is just a basic formal definition. So whenever we're trying to put something or say something, that have a formal definition, and this is the formal definition of this machine learning, that it is a programming language for the computers to optimize the performance or to make a prediction for the future on the basis of the past data. Now this learning, there is a term that is machine and the learning. So machine is what we can understand as a machine as a CSP student, that it is a computer. Most general definition of the machine, it is a computer. Now, what is this learning? The learning means that a computer program, forget about the computer program. Suppose you are a human. How will you learn something? How will we learn something? So suppose when you are trying to do something for the first time, we learn from two generic scenario, right? One, by our past data, by our previous experiences, or someone have tried to teach us that how this thing can be done. That is one side. And second side, that we are going to learn by ourselves, right? So two scenario, if we are trying to learning by ourselves, that is the experience for us. And if I am trying to learn from others, that how it was done by the others, or how someone has tried to teach me that how this thing can be done, so that is an experience also from some other person. So similarly, a computer program, in the term of this learning, it is also learned from the experiences with respect to some class of tasks and some performance measures, right? So a learning here is, there is three basic criteria, that is learn from experience, learn from experience. Secondly, with respect to some class of tasks, with respect to some class of tasks. Learn from experiences with respect to some class of tasks, and there is a performance measure, right? So the anything you can take as an consideration, that suppose you are trying to play a game of chess, you are trying to run, or you are trying to, for a bicycle or a bike or a driving, whatever you are trying to do, all the things have either a past experience or you are learning it from your own end. That is called the learning. And each time when we are doing it, each time, suppose previously you have played a game of chess, so whatever the mistake have been made by you in your past game, in your future game you will not try to repeat that one, you will try to improve it. So improving myself also from my past experiences, that is called the term of learning. Now this learning, there are some components, there are some basic components of this learning, right? So this learning processes, maybe a human or for a machine, any can be anything. It can are four components basically. What are the four components? For that, let us just quickly draw a simple diagram, right? Suppose a data, okay, concept, inferences. Okay, now this data have a part of data storage, right? Concept is an abstraction. Lastly, inference, it is a generalization. right? And then the evaluation, there is a term that is called evaluation. So this data in parentheses, this is the concept. Okay. So data is attached, or this particular concept is inferences, and there is a evaluation will be happening each time. Okay. So if I illustrate all the scenarios that this data, there is a several type of data is present in present of this, considering the current scenario, current situation, the data, the number of data, the data storage is huge. The volume of data in today's era, it is huge, right? So that's why we are dealing with this data science, machine learning, big data, several type of concepts are there. From that large pool of data, we have a concept. We are trying to gather some concept, inferences that makes us some protocols that is helping us to get the learning, and then the evaluation means to upgrade myself. So now if I illustrate one by one, the first part is data storage. The first term is data storage, that where we can store a simple data. This is the term very similar to some database. Data storage means facilities for storing and retrieving this huge amount of data, as an important concept of this learning process. The data, if we are working on a data, we need to store that particular data in a data storage part. So humans and the computers alike utilize this data storage for some reasoning or for some work performance, right? This is the part of this data storage. Now coming to the part of this abstractions, it is saying, or abstraction is what? That is process of extracting the knowledge from the stored data. So abstraction is the process of extracting knowledge. Abstraction is the process of extracting the knowledge from the stored data. So it is the process of extracting the knowledge from the stored data. And this involves the general concept. So whatever the data is present, to create a concept from that, creation of the knowledge involves this application of models and creating some new models. So in this context, there are two scenarios, that is a training data set and that is a test data set. So filtering a model to create a model from a data set to make that model ready for the future prediction is done by this training data set. The model is trained and the data is transferred to get some particular concept, right? Third one, generalization. The third term that is present here, that is generalization. So what is this generalization? Is saying that this generalization describe the process of turning the knowledge of stored data into the form that can be utilized for some future action. So generalization here, from the training data set, we are extracting some concept, and then that concept is turned or put in some scenario for some future actions. Here comes the concept of test data set. From the trained data set, we have extract a particular process, particular pattern, and then we are going to use that for our future references. And evaluation is the process of giving the feedback to user, for the user to measure the utility of the learning knowledge. Means how much my model is working, how much the accuracy it is done, whether it is working perfectly fine or there is some problem with that. If any problem, then we need to recheck of all the scenarios. So these are the four basic concepts or four basic components of this machine learning: data storage, abstraction, generalization, and the part is evaluation. These are the four terms: data storage, abstraction, generalization, and the evaluation. Now the applications, I have said already, the railway IRCTC website, the weather forecast, then some retail businesses, right? Study the customer behavior. Means a very example here that comes in my mind, that if we are trying to check out some products in Flipkart, Amazon, wherever. Right. After looking out for the product, then what happened usually that in each and everywhere we are going to get some suggestions regarding that product or with respect to that particular product. Means this can be your suggestion, you can might look for this. So how it can be done? It is just a study of the customer behavior, that what is customer looking for into the web, into the different e-commerce platform. The customer is looking for what particular scenario, and then there are some more suggestions is coming to the customer or to the user, that you can also look out for this scenario, right? So bank also analyzes all of its creating scenario, manufacturing, then the medical diagnosis scenario. Means in each and everywhere this machine learning is nowadays a huge name, and it is giving or it is transforming the scenario, the era into some advanced stages, right? So this learning, machine learning models, the term machine learning, this learning have some models. Usually there are three basics models, that is logical model, geometrical model, and probabilistic model. Usually there are three learning models are present. First one, logical model. Second one, geometric models. And third one, probabilistic model. So these are the three basics model that is helping in the term of this machine learning. And in the very first term, I have write something that makes a prediction. And this prediction is done by the statistical or probabilities model. We have learned the probability in our class 11 and 12, the mathematical part, the probability to predict something, to probable something. That probability is a very important part in this particular, in the name of this particular machine learning, right? Now, this probabilistic model, logical model, or this geometric model, wow, what is this particular? We are going to find out. First, as a basic example, the logical model is only the logical expression. Geometrical model means the geometry of any instance spaces, means some graphs, some charts, these are this. And probabilistic model to probable classify some spaces. So first, if we let us talk about the part that is logical model. So what is this logical model? It is use of a logical expression to divide the space into segments and creating some grouping models. So talking about the first part, the logical model. So this logical model is an expression that have some output as a true or false. Some values will be coming as an output of true and false. So whenever some data is grouped using some logical expression, the data is divided into some grouping for the problem that we are trying to solve. A classification problem, the instances of the group, this type of problems. Means when we have some output of true and false, whether this is true, whether this is false, that comes to the part of this logical model. Some Boolean value will be coming as an output, right? The logical, this models, and this there comes the part of the concept learning. The value will be coming as a particular scenario. So if I say a something as an example, that will be help us to understand the scenario of logical model, right? Let us write an example that will be very easy task. Okay, so this is an example that is present here, that depending upon each and every scenario, depending upon each and every scenarios of this sky, air temperature, humidity, wind, water forecast, can a day we call that we can enjoy sports on this particular day or not. We can enjoy this particular day or sport or not, right? So if I write some values, if I write some data in this particular scenario, suppose first, second, third, and fourth. For the first one, suppose for the sky, it is saying that for it is sunny, then it is rainy, and lastly it is sunny, right? For four options, there is four values have been written, right? Then for the part of this air temperature, for the part of this air temperature, suppose we are saying warm, okay. For humidity, there are some values have been present. Suppose normal, high, high, high. Then for the wind, some values are present, that whether how much wind is going on. Suppose strong, strong, low, strong. For the next part, that is water, and it is saying that whether high or low rain is going on or not, high or low rain. So suppose there is low, low, high, and low, right? For the forecast, there is saying some whether it can be changed or not, whether it can be same or rainy or that. So suppose same, same, and change or same. So these are some values have been present. Now depending upon each and every term, each and every component of this particular day, we want to find out that whether we can enjoy sports on this particular day or not, whether we can enjoy a particular sport on this day particular or not. So first of all, when there is a rainy season, when there is raining, obviously we cannot enjoy any kind of sport, means we cannot play any kind of sport. So quickly, for the first one, for the very first scenario of this raining, there will be the option will be no, a very basic term, because for a rainy day we cannot. The first scenario, when it is saying that it is rainy, we cannot actually enjoy any kind of sport, right? Now the next part is sunny. The day was sunny, or when there is two basic part. So when the day is sunny, we actually can enjoy sports. Actually, in the morning, in the evening, we can play any kind of sports. So in that scenario, we can say yes, yes, and yes, right? So these are the particular scenarios on which we can actually say, means it is just a very basic example of logical model, means how we were actually finding out some logic, we actually finding out some values of this logically saying that whether we can enjoy some sport or whether we are not, we cannot enjoy any kind of sports or not. So yes, yes, no, yes. So when there is raining, we cannot obviously enjoy any kind of sport. So this is just a very, means a very easy example that we are getting some concept depending upon some attributes of this logical model. So this concept, a concept learning, we can also talk about, we can also name this as a term of concept learning. We can also name this as a part of this concept learning, and this showing from this particular table some set of data are present. Wait, just a minute. So some sort of data is present depending upon the days, and there is some attributes are present in this particular day. And we are there is a task that is enjoying esports. Some concept is actually performing to predict the value that whether we can enjoy the sport on this particular day or not. Right. So this problem, having the instances, there are several identification. Also, we can make it to the Boolean, that is true for one, false for zero, right? So depending upon the scenario of yes or no, instead of yes or no, we can also put some values of this one and zero, that is some true, for some yes value, for some true value, we can say it is one. For some false value, we can say 0. The Boolean expression can also be performed, right? Coming to the next part, that is our geometrical model. That the logical model is something different, that where we have some values, some data are present, and we are trying to find out some concept on this particular data. But this geometrical model, the geometry, wherever the term geometry comes, that comes in our mind, that is some graphs, some planes, some XYZ spaces where we can put some data, we can put some values and create a graph, create a chart, this type of things, right? So this logical model, apart from this logical models, this geometrical models is also actually doing some spaces, working on some spaces. The features here are actually described as the value point, the dimensions such as y and x axes, and for three-dimensional spaces, x, y, and z, right? So we can actually draw some figure, draw some graphs on that particular scenario to understand the predictable output much better. There are some models, some linear models, distance based models. There are different type of models are present, right? So suppose I'm trying to particularly get an output. I'm trying to draw some particular graph. These are two-dimensional graphs. Some values have been placed, x and y. Okay. In the x-axis, there are some values are present. Suppose 0, 1, 2, 4, 5. Okay. And similarly, in this particular scenario, some values have been placed. Some values have been placed, right? Now, this linear model, this is a linear model. Actually, some linear line is going on. The linear model in this, the function is represented as a linear combination of the input, some x and y values, some x and x, y axis have some values. So depending upon some points, depending upon some values, we can plot a particular graph here. Depending upon a very simple scenario, that is y equal to mx plus c, that is we have studied in our previous means at the classes of 11, 12, y equal to mx plus c. Depending upon this particular scenario, we can get a draw line, we can put some values, and this particular lines can be drawn. So geometrical concept, to whatever the data, whatever the values have been present, put that particular data, put that particular value into a particular graph, form a particular shape of the graph, and get a prediction of the output, right? So these lines, this graph, by drawing this particular graph, suppose there is a line also another, this something like this, right? So by these particular lines or by this particular graph, what we can understand, that suppose considering this day, these are the values, means at each and every point, that each and every point there is some rises cases, the case or the things is rising day by day, considering it is a COVID graph, right? Suppose it is a COVID graph for the day 1, day 2, day 3, day 4, and 5, and depending upon the continuation, right? So from the very starting day, from the first day, the graph is at this particular point. For the second day, it is here. For the day 4, 5, it is here. Means the cases are rising. Now, after a certain period of time, we can see that now the things is coming down. The things are coming down, right? So maybe at day 14, 15, 16, we can say the graphs for the COVID cases are rising down. So the prediction, depending upon the cases, depending upon the values, the prediction is made that yes, after so many days, then it can be fully neutralized. The COVID will not be there, right? So when this will be done, this will be reaching this particular position. At the means there is a value of 0 or the baseline. Suppose considering it is a value of 0. So at the baseline, then we can say yes, no COVIDs are there. So this is some prediction. the value depending upon the whatever the data we have, plotting that through a graph, we can also predict some result, we can predict some outputs also. So these models, the geometrical models are stable, and very more of the high, the value of the data sets of the high are in training data. Depending upon the training data, we can plot that training data into the graph, and then we can predict something. And there is some distance based model, that is find out some calculation, find out some values between two distance at particular point. So distance based model, or the most importantly I can say Euclidean distance based model. The term Euclidean distance based model is a very important term with respect to machine learning, data science, and artificial intelligence in all the fields, because calculating the points, calculating the value points within each term is a very important here, right? So we will look each and every term in our upcoming days, because we have lot to talk about. And lastly, the very concept of this probabilistic model, that is fully depending upon the statistic and probability, right? So to predict something, the probability of this particular value to get the output from this particular value, that will be the probability of this, the probabilistic model actually, right? So here are some example. We can say that naive Bayes algorithm, Gaussian process algorithm, regression algorithm, these are the scenario that is present in our probabilistic model, right? So these models are the basic theoretical part, but when the term machine learning comes into the scenario, the theory, apart from the theory, the practical thing is the basic thing. The actual thing is our practical part, where we are going to implement and learn about all these things. The theoretical part is another issue. We need to learn the theory, we need to understand the theory to perform the task, but it is much better option to learn the practical part also. But as it is not present in your syllabus, the practical is not present, but in your sixth semester, whether you will have done it or not, our students, the CSC cybersecurity students, have performed some particular labs on this particular in the machine learning scenarios of Python programs we have done here. So okay, fine, no issue, forget about those previous things. Now this machine learning, the learning system, the design of this learning system, what is the scenario? Looking into the learning processes, the goal of the learning. Now when we want to design a particular learning system, following whatever the scenarios we have 4 or 5 components to design a particular model. We have 4 to 5 components to design a particular model. What are the 4 to 5 components? First one, type of training experience. This is the first component. Just a minute. Okay, after this type of training experiences, choosing the target function. Choosing the target function, then choosing a representation for the target function. Choosing a representation for the target function. Then fourthly, we can say approximation algorithm for the function. Approximation algorithm for the function. And lastly, the model. Whatever the model we are trying to design, the final design of the model. The final design of the model. So these are the 5 components, the key components that is helping or needed in to learn or to design a particular model. the type of training experience. This type of training experience means that whatever the previously past the thing, there's the whether we have learned it directly or some indirect experience is involved here, direct or indirect experience we can say. Then we can say that is the training experience was good. Choosing the target function means that when whatever the things when we are performing, the target function means the data, basics, the data, the correct or appropriate data we need to find out for our task. Means as an example, we can say suppose we are trying to check or predict some weather forecast. So we need some data that is depending on the weather forecast. We don't need any data for railway reservation system, for contact number, for names, anything. So the data, choosing the target function means choosing the appropriate data, right? Then the part we can say the third one, some choosing an approximation algorithm. No, before one, there is a representation of the target function means to filtering all the data, removing the noises, all the scenarios. Approximation algorithm means to particularly find out some algorithm that will help us for our model to predict some output. And lastly, the final design, the shape of and all of the things. So these are the components that is present that is needed for learning or to design a learning system, right? So up to this particular part, we are going to talk and discuss because the time is going to end in a very quick scenario. So I would like all of you kindly write your names in the chat box for your attendance purpose. Those who are from Dumka Engineering College, kindly write your name and then your college name in a short form of DEC, right? So it will help us to understand that yes, these people are from DEC, right? So quickly write your names in the chat box for the attendance, otherwise you will miss it. So the scenario is as the time is going to end for today. The question session we cannot perform it today, so we will going to talk or discuss if we will have anything. We will ask in our next classes, right? So time is going to end. So thank you all for joining into the session. Take care and stay safe. We will meet in our next class.
Thank you, sir.
Thank you, sir.
Thank you, sir.